Madam, okay. Medicine under Madina. What to mark? Second floor. Third is second floor. Third me. Office first floor. Second room. எத்தாலே ஜாயிங்கடா கீழ இறக்கத்துல அருண் சார் இருக்காங்கல்ல அந்த மீடியா ரூம் இருக்குல்ல மீடியா ரூம் பக்கத்துல ஸ்டாண்ட் இருக்குங்க அதான்
Good morning, all. Good morning, all. Welcome to Free Online Workshop 2025. Topic: Introduction to Blockchain: The Future of Internet. Organized by ECLearnix EdTech, Coimbatore, Tamil Nadu, India. Welcome to Free Online Workshop. Upcoming courses and programs, certificates will be provided for every program. STTP, short-term training program; FDP, faculty development program; skill development course, UX UI design; skill Saturday, online free workshops; online conferences; journal publications. Mobile users kindly download this on Play Store, our Easy Learning app. Register now on www.easylearnix.com and contact for the given name. Today is our expert speaker, Dr. U. Batmavati, Assistant Professor, Department of Computer Science and Engineering, School of Engineering, Shivnara University, Chennai. Dr. U. Batmavati is working as Assistant Professor in the Department of Computer Science and Engineering, School of Engineering, Shivnara University, Chennai. She has completed her BE Computer Science and Engineering in the year 2009 and ME Computer Science and Engineering in year 2011 from Annamalai University. She completed a PhD from National Institute of Technology, Puducherry. She has more than 13 years of teaching experience. She has published in reputed journals and presented in many international conferences. She has organized workshops and FTPs and delivered sessions in many reputed organizations. Her research interests include networks, security, blockchain. Now, I hand over the session to Dr. Modi, ma'am.
Am I audible, ma'am?
Yes, ma'am.
Ma'am, uh, am I audible?
Yes, ma'am, you are audible.
Okay, thank you, ma'am. Thank you so much for the introduction. Can we start the session now?
Yes, ma'am, you can start.
Yeah, just confirm whether my slides are visible. My slides are visible, ma'am.
No, ma'am.
Ma'am, is my slides visible?
Ma'am, your slide is not visible, ma'am.
How about now? It's visible, right? Murli, ma'am?
Ma'am, your slide is visible. You can start, ma'am.
Yeah, thank you. Thank you so much, ma'am. Thank you so much for the opportunity. So the today's session title is Blockchain, the Future of Internet. Let me first give you an outline of my presentation. First, I'll be discussing about the introduction to blockchain, then the cryptography used in blockchain and the research in blockchain and the applications of blockchain. And in particular, I'll be discussing about how blockchain can be used in healthcare and the various research ideas if you want to take on blockchain in healthcare. So coming to the introduction to blockchain, first of all, I would like to let you know how blockchain is related to cybersecurity. And there are some key terms that everyone should know, like what are distributed systems, what is a ledger, and what is a cryptocurrency. And then I'll be giving the definition for blockchain, structure of blockchain, and history and origin of blockchain. Then we'll be discussing the components and how does it work. Okay, and these are related to the cryptography part in blockchain. And if you want to carry out research in blockchain, then these things that you should know. And then I'll be discussing about a few applications of blockchain. Okay, let me first go to the introduction to blockchain. So everyone knows what cybersecurity is. Can I get some answers from you? What is cybersecurity? Any idea about cybersecurity? And if we say blockchain, it is related to cybersecurity. So I just want to know what is cybersecurity first. Can anyone answer for this? So when I say cybersecurity, it is comprised of two terms. One is cyber and the other one is security. So what is cyber actually? Simply we can define it as online world, right? Security, we don't need any formal definition. We know that it's nothing but free from danger. So when I say online world, when the online world started, it was Web 1.0. Like, what is this Web 1.0? So when the world of internet started, we can work with the internet, but the problem with the internet is it is very much static. It's not dynamic. That is, you cannot interact with the web. Whatever the pages that are displaying, that you can read out. That is, Web 1.0 is static. Simply, you can call it as read-only internet. Then comes Web 2.0, which is nothing but the one which we are working today. So here what we are doing, we are reading the content as well as we are writing the content. Suppose if you want to post some videos, you can post your own videos. If you want to give some comments for the videos, you can interact and you can give the comments for the videos. And while if referring some Google pages, you can navigate through to the next page by clicking on some hyperlinks, right? That's what is Web 2.0. Whereas in case of Web 1.0, it is just read only. You cannot write. But there are very few content writers who can write onto the internet. Whereas in case of Web 2.0, it is both read as well as you can write some contents onto the internet, right? So what is the major problem with this? We are very happy with the internet today, right? We don't find any problems. But have you ever wondered that whenever you think of some content, automatically that content would be displayed in your Google Ads, right? Suppose, for example, if you have a search for a T-shirt, then you might have noticed that the T-shirt ads would be displaying in all the web pages that you search through, right? How is it possible? Have you ever wondered? Have you ever thought of it? Sometimes you'll be discussing something with your friends, but the next day you'll be noticing that it's being displayed in your mobile. So all these things happen because of the centralized authorities. So the problem with this Web 2.0 is everything is centralized. You have some centralized authorities or centralized owners who control your data. So when you take this Web 2.0, you are not the owners of the data. So we need some revolution which could bring, which you could do. You can read the data, you can write the data, as well as you should be the owners of your own data. So that's why we are just moving to the world of Web 3.0, where you can read the contents write the contents as well as you can own your own contents. That is, you are the owners of your contents, right? But okay, I said I want to be the owner. But how can I become the owner of my content? Simply storing it in one place, I cannot be the owner, right? If I depend on some central authority, then that central authority is going to be the owner of my content. And what he's going to do is just going to steal all my contents and sell it to someone, and he is going to earn money. So in Web 3.0, what we are trying to do is we are going to be the owners of the contents, and we are going to earn the money for our own content. Okay, but how can I do it? I need some technology, right? That technology, how it should be? It should be more secure, it should be transparent, and it should not be a centralized one. It should not be a centralized one in the sense, then it should be a decentralized one. So let me know, is there any technology that is decentralized as well as which could be able to give you the security features and transparency features? Can anyone tell me, is there any technology that can provide us with all these things? So, the obvious solution is what? Blockchain. So, now you could understand how the blockchain is called as the future of the internet, because we want the decentralization. So, if you want a decentralization, you need some technology for that, and the only technology that would provide you with the decentralization as well as trust, security features, and transparency feature is going to be the blockchain. Okay, so before discussing what is blockchain, you should know what is a centralized system and what is a distributed system. So, centralized means you are going to have the central authority who is going to control everything in the internet. That is, the data and information that is being transferred is controlled by a centralized one. Whereas when I say distributed, there is not going to be any centralized authority. Whatever the data is going to be, everything is distributed among all the nodes in the network, right? So these are some definition for distributed systems. So when I say distributed systems, it is nothing but the network of independent computers that work together to achieve a common goal, right? So before discussing what is blockchain, we should know what is a ledger. So you must have seen this ledger book in the olden days, right? While watching some movies, also you could have noticed that the shop seller would be having a book which is nothing but a ledger book, where he just writes the transactions that he performed on that day, and what about the balances he is having. All those information, everything will be recorded on one notebook, and that notebook is called as what? The ledger. So when I say ledger, it is nothing but it is a book in which we are going to have an opening balance, brought forward balance, and some list of transactions, right? This transactions is going to be either it is going to be a debit transaction or it could be a credit transaction. Along with it, we are going to have some ending or closing or carry forward balances. So when we say ledger, there should be some properties for the ledger, right? The first property is chronological order. So whatever the transactions that is going to be recorded onto the ledger, everything should follow a timeline. So at what time the transaction happens, based on that time, it has to be recorded onto the ledger. So integrity, it means whatever the data that has been entered into the ledger, it should never change. That is, no one should be able to change the data that has been entered into the ledger. Then security means, yeah, of course we need security of the ledger. It should be maintained by trusted entities so that no one else would be able to steal the record or change the record. And confidentiality is, it is accessed only by the authorized person. Suppose if the ledger has to be maintained by the faculty, then that ledger has to be accessed only by the faculty and not by the student members, right? This is what is referred to as confidentiality. So, whenever you hear the word blockchain, immediately you could have remembered this term cryptocurrency. What is this cryptocurrency? How does it differ from our original currencies, whatever the currencies that we are using in day by day? Like, see, everyone makes use of GPay today, right? GPay, PayPal. So no one is carrying the cash at hand. So whatever the uh, transactions that we are doing using this GPay or PayPal or whatever it is, everything is called as what? Digital currency. So when I say cryptocurrency, it is also a digital currency. But how does it differ? The way it differs is it is maintained in a decentralized fashion. Okay. So cryptocurrency is what? It's a digital currency, but in the form of decentralized digital currency. So here you need some cryptography, but you don't need any central authority. So when I say GPay, I need bank, right, to check whether I have the balance to send. So if I don't have balance, automatically some authority, some central authority is going to say that there's no balance in your account to make some transactions, right? But whereas in case of cryptocurrency, we don't have any centralized authorities. But how this happens, how the transaction is going to happen, here every peer is going to have the control. That's why it is a peer-to-peer system, right? And the first cryptocurrency is Bitcoin, and it was founded in the year 2009, and it is the best known today. Now we are just moving to what is blockchain. So when I say blockchain, simply you can call it as block plus chain, right? So what is this block plus chain? Another simple definition is chain of records, where you are going to store some records and everything is going to be chained manner, right? So when we say that I'm going to store the records, it is naturally going to grow, right? So you can also define blockchain as the growing list of records. And the formal definition is it is a distributed ledger technology which is used to record as well as store data without the use of trusted third party. That is, what does it mean? Where you can store all your data, but you don't need any central authorities. So, what is the meaning of central authority? Suppose, for example, if you are going to make use of financial transactions like banking applications, then you don't need any banks. So here the role of bank is not at all needed when you are going for the blockchain, right? This is the definition for blockchain. And coming to the properties of blockchain, the first property is immutable. In the sense, whatever the data that I have recorded onto the blockchain is not going to be changed. No one is able to change the data that has been written onto the blockchain. So that's why it is said to be immutable. And the second thing is distributed. Yeah, of course, right? Since the data is going to be stored on all the nodes present in the network, it is going to be a distributed thing. And the third thing is consensus. So I mentioned that there is no central authority, but how do you find that this particular person is having some balance and he is able to make some transactions? How can you make everyone agree to some transaction? Through the help of consensus mechanism. Okay. Then the next thing is it is transparent. So whatever the transactions that you are performing on the blockchain, everything is transparent to every other peer that is present in the network. And the next thing is security. Okay. So when we say that whatever the thing that are stored on to the blockchain is immutable, automatically the security feature comes, right? And tamper-proof. No one is able to change or alter the records of your blockchain. So this is the definition and the properties of blockchain. Let me know if you have any doubts. You can stop me at the middle if you have any doubts. So coming to the generic structure of blockchain, so this is how the structure of blockchain looks. So usually you will be having number of blocks and the blocks are going to be chained together, right? Usually the first block is called as the genesis block. And whenever we say any block, there are two things that is going to be present inside a block. One is the block body and the other one is block header. Okay. So you see we have the block body and we have the block header. So what is this block body? It is nothing but the transactions that is happening inside the network. All the transactions will be stored inside the block body, and the block header, it is going to contain some information about your block, right? So actually this is how it looks. The first one is Genesis block followed by so many blocks, and each block is linked to the previous block, right? Here you see we have the two things, block body and block header. Block body is going to have the transactions, right? And the block header is going to have some information about the block. So what are the information that is going to be present? We are going to have the hash, medical rotary, timestamp, nonce, n bits, and version. What is it actually? Let me explain. So here, this is with respect to the Bitcoin blockchain. This is how it looks. So inside the block content, we have a number of transactions, and inside the block header, we have medical root, difficulty, previous block hash, timestamp, and nonce. Okay. So here, how is this medical root calculated? I mentioned we have some transactions, right? The transactions are just converted into some hash values using some hash algorithms. When I say Bitcoin, it is going to make use of SHA-256 hashing algorithm. Okay, so this hash value, the transaction will be taken. For every transaction, the hash value will be found out, and finally until you reach a single hash value, this process will be repeated again and again. So that final hash value is going to be the medical root. And this previous block hash, it is nothing but the hash value of the previous block. Okay. So we said that, I said that the blocks are linked together, right? How are the blocks linked? So here, every block is going to store the hash of the previous block. This is how it is going to be linked. So next is timestamp. Timestamp is nothing but the time at which the block is generated. Okay. Then difficulty and nonce. These are two are the most important things. Okay. As of now, you just think that nonce is nothing but it is going to be some number, some random number which is going to be used only once. So this difficulty, it is nothing but it is some puzzle. So whenever we say blockchain, we have some blocks and the blocks must be added to the blockchain, right? So how it is being going to be done? There are a few persons called miners who is going to perform this task, adding the blocks to the blockchain. So what are these miners going to do? They are going to solve some difficulty. That is, they'll be given some puzzle. They are supposed to solve that puzzle, and the miner who solves the puzzle first, only his block is going to be added to the blockchain. Okay. So here, the puzzle could be anything. He could be asked to solve and find a hash value which starts with three zeros or 4 zeros. Or something would be given as a puzzle, and for which you can use a number which is called as nonce, and using that nonce he is going to solve that puzzle. The one who solves the puzzle first, only his block is going to be added to the blockchain and he will be rewarded. Okay. So this is some emergence of blockchain. How does it come? So here the first blockchain came with the Bitcoin. Okay, it was in the year 2008 and by Satoshi Nakamoto. Okay, so initially blockchain was used only in the cryptocurrencies, but later there came a person called Vitalik Buterin. What he thought is, why do we need to use blockchain only for cryptocurrencies? Why don't I use it beyond cryptocurrencies? So he just come up with the idea of smart contracts. Okay, then comes the idea of decentralized applications. That is, we can design decentralized applications using blockchain technology other than the cryptocurrencies also. So then altcoin came into picture, Ethereum, so many blockchains came, right? In the year 2019 to 21, the people started focusing more on scalability and interoperability issues. Okay. Then in the year 2021, decentralized finance and non-fungible tokens came into picture, and now we are trying to integrate all our traditional systems with this blockchain technology. How can we make use of this blockchain technology in all the applications? This is what the research is going on. So these are the components of blockchain. We have the peer-to-peer network, public key cryptography, distributed ledger, consensus protocol, smart contracts, and some client softwares are needed, and the wallet. So this public key cryptography I'll be discussing while we are discussing the cryptography part. We have discussed what is a distributed ledger and consensus. It is nothing but some kind of agreement. As of now, we understand it is nothing but a kind of agreement. Okay. Then smart contracts. When we say smart contracts, it is nothing but it is in layman term, if we want to define smart contract, it is nothing but the code that we are writing. Whatever the programs that we are writing in the blockchain, it is referred to as smart contracts. Okay. Then we have some client softwares. We need some softwares to work with the blockchain technology. And comes the wallet. So if you want to spend some amount, you need some wallet, right? What is a wallet actually? Simply we can call it as a purse, right? Wallet is nothing but the purse in which we store some amount. So likewise, in case of blockchain, here wallet is nothing but it is like a purse in which we are going to store our keys. Keys in the sense we need some keys for performing the transactions in the blockchain. So those keys are stored inside the wallet. Whenever you want to make some transactions, you will make use of such wallets and you will make the transactions. Okay. So those keys are going to be your public key and your private key. That's what is given here. So here your public key is similar to your account number, whereas your private key is similar to your account password. Everything is stored inside the wallet and using which we are going to make the transactions. So there are different types of blockchain wallets. One is hardware wallet and the other one is software wallet. Okay. So when I say hardware wallet, it is nothing but it looks like a small device like a pen drive where you are going to store your keys. So other than that, everything is a software wallet. Here you have the web wallet where you are going to, in which in web you are going to store your keys. Mobile wallet, you are going to store keys in your mobile. Desktop wallet is where you are going to store your keys inside the desktop. Okay. These are some benefits. So as I mentioned, what is smart contract? It is nothing but the code. So here it is given as it is an automated or self-executing contract that holds the agreement. So what for we are going to write the code? For coming to some agreement, right? So I'll be delivering you some product. You are supposed to give me the cash. Okay? This is a kind of agreement that a manufacturer have with the customer. So when I want to execute this agreement, how can I execute it? With the help of some code. And that code is nothing but the smart contracts. Okay. So here the idea of smart contract was first proposed by Nick Szabo, and the true implementation came into picture when blockchain came into existence. So these are some benefits of smart contracts. Coming to the consensus. So as I mentioned, what is this consensus? It is nothing but in simple definition, we can define it as common agreement. Okay. If everyone in the network wants to guarantee some transaction or validate some transaction, how can they do it? By using some consensus mechanisms. It is nothing but some set of rules they are going to make use of. So this consensus is some set of rules to ensure that all the transactions that are occurring in our network are genuine, and all the transparents all the participants in the network are going to agree on the single value of the network, right? That is consensus. So this consensus is a topic of research for the past 30 years. And when we say consensus, there are different types of consensus. We have this proof of work, proof of stake, delegated proof of stake, proof of capacity, proof of authority, proof of elapsed time, Byzantine fault tolerance, proof of activity, and the list goes on actually. Okay. Whereas this Bitcoin makes use of proof of work consensus mechanism, and when we say Ethereum, it is making use of proof of stake consensus mechanism, and therefore now I think it is making use of delegated proof of stake consensus mechanism. And when we say other things like Hyperledger, it is making use of Byzantine fault tolerance consensus mechanism. Every blockchain is going to make use of some form of consensus. Even if you design some blockchain, what you can do, you can write your own consensus mechanism, right? As of now, we have discussed what is blockchain. Now we are going to discuss how does blockchain work. We know that blockchain is a record. Simply, blockchain is nothing but some records are going to be stored inside it. And for storing that, we need some smart contracts as well as we need some consensus mechanism. Okay, how does it work? So initially, propose some transactions. Okay, so that is transactions are proposed. Once you have proposed the transaction, then collect all the transactions and create it as blocks. So now I have so many blocks. Every block is having some kind of transaction. Now the next thing is what I should attach this block to the blockchain, and before that I should reach the consensus. Okay, the transactions that are present are valid and these transactions are accepted. So how are we going to do it? We are going to do that using the consensus mechanism. So once the consensus is done, now the blocks are collectively and securely linked together. And now the block is linked to the blockchain network. Okay. So what are the different types of blockchain? So when we say blockchain, we have public blockchain, private blockchain, and federated or consortium blockchain. So this public blockchain, yes, from the name itself, we can say that it is public. Public in the sense it is open to anyone. Anyone can access the network, anyone can join the network, and everything is transparent in this network, right? So the Bitcoin is a good example of public blockchain. Suppose if you want to mine Bitcoin, yeah, of course you can join the network and you can mine the Bitcoin, right? So that's why it's a public blockchain. You don't need the permission from anyone. You don't have any central authority. So next is what? Private blockchain. So private blockchain means from the name itself you can say that some blockchain is private to some organization, right? It should be private to one particular organization. So when it is private to some organization, we need someone, some central authority or someone in the center to take care of everything, that is to control everything, right? Then federated or consortium blockchain. So from the name itself, we can understand that it is the consortium of members who are involved in this kind of blockchain. So here, let me tell you an example. Suppose if I ask you to design a blockchain for your organization, now tell me whether it would be a public blockchain or it could be a private or it could be a federated or consortium. So I am working in a university. Suppose if I am designing a blockchain for my university, it could be public or private, or it could be consortium. What it could be? Of course, it cannot be public, right? Why? Because I cannot allow anyone to join my network or anyone to join inside the my university blockchain. So whom do I allow? Only my faculty members and my student members will be allowed inside that, right? So those who are working in my university only can join the network. So suppose if they want to join the network, I have some central authority, some administrator who is going to certify that only he belongs to the organization and he can join the network, perform transactions in the network, right? That is the private blockchain. Next is what? Federated or consortium blockchain. So here, federated or consortium blockchain, suppose think that I am designing some blockchain application for the supply chain management system. So here, who all are the participants involved? Yes, of course, the participants are the manufacturer, the wholesaler, the retailer, and the customer. All are going to be the participants, right? So here we don't have any one organizations. Here we are going to involve a number of organizations. So when a number of organizations are involved in a network, then we are supposed to design a what? Consortium blockchain, right? So these things are explained here: public blockchain, private blockchain, and consortium blockchain. Okay. Next is what? Versions in blockchain. So when we say versions in blockchain, there are four versions in blockchain. One is blockchain 1.0, blockchain 2.0, blockchain 3.0, and blockchain 4.0. So when the blockchain came into existence, it was only the cryptocurrencies, right? that blockchain 1.0 was dealing only with the cryptocurrencies. But later people started to think, other than cryptocurrencies, how can we make use of this blockchain technology? And that's how the smart contracts came into the picture and developing the decentralized applications came, right? So blockchain one, when I say blockchain 1.0, it is nothing but the cryptocurrencies. But when we say blockchain 2.0, other than the cryptocurrencies, where we can make use of this blockchain. So here, it in case of blockchain 2.0, decentralized applications came into picture. And then comes this blockchain 3.0. So what is this blockchain 3.0? So we know that blockchain is a distributed ledger technology, meaning that every node in the network should store the ledger. Suppose think that I am asking you to design a blockchain application for your smart home, right? So smart home, what do you mean smart home? What could be present inside a smart home? Smart home means we have the smart AC, we have the smart washing machine, we have the smart fridge, right? Suppose if you are asked to design a blockchain application where these smart devices can talk to each other, then what could be the major problem in this? Yeah, of course, storage, right? You have the storage issue, you have the computation issue, right? Because blockchain needs more storage, blockchain needs more computation. So people started to think, how can we integrate this blockchain technology with the IoT devices? IoT devices are nothing but the Internet of Things devices. So because of which this blockchain 3.0 came into picture. So here people started to integrate the blockchain technology with the IoT devices. And the best example is IOTA network. And then comes the blockchain 4.0. So here this blockchain 4.0, it just concentrate mainly on how the different platforms can talk to each other. Suppose think that I am designing some blockchain application using some blockchain framework. For example, it could be Ethereum. And my friend is designing some blockchain network and he is making use of the Hyperledger Sawtooth or Hyperledger Burrow or something. So now the thing is, we want the communication to happen between this blockchain to other blockchain. So as of now, there is no way blockchain can talk to other blockchain. So this blockchain 4.0, what it is trying to do, it is trying. So here 1.0 is cryptocurrency, 2.0 is decentralized applications, 3.0 is IOTA, and 4.0 is cross-chain platform. Cross-chain applications are interoperability. So that's what is mentioned here. Blockchain beyond currency, smart contracts, and blockchain 3.0 is
Excuse me, ma'am. Sorry for
devices,
the
and
interruption. Your voice is
blockchain
breaking, ma'am.
4.0 is cross-chain communication.
Excuse me, ma'am.
Now we just moving to cryptography blockchain. So
Ma'am,
far we know how blockchain works, what are the different types of blockchain,
ma'am, your
and what
voice
are the
is
versions
breaking,
of
ma'am.
blockchain.
Not audible
But
clearly.
how crypto are we really making it மேம் இப்போ கிளியரா இருக்குதான்னு பாருங்க. Hello.
Yes, ma'am. Now it's clear. You can start.
Okay, thank you, ma'am. Is my screen visible, ma'am?
No, ma'am. It's not. No, ma'am. It's not visible.
Okay, just a second.
Now it's visible, ma'am.
Yeah, thank you, ma'am. I'll start now. So here, I'll be discussing about the cryptography, how cryptography is used in blockchain. So here, what is cryptography? Actually, it is nothing but whatever the information that we want to send, everything we are going to hide in some form. Okay. Why do we need to hide it? So that the secure communication can happen. So here, what we are going to do, simply convert the plain text into ciphertext messages. Okay. So here, I'll just fastly go through cryptography. So here, when I say cryptography, there are two things involved. One is encryption and the other one is decryption. Encryption means it is nothing but converting the plain text to the ciphertext. Ciphertext is nothing but the unreadable form. It is done at the sender side. Whereas decryption is converting back the ciphertext to the plain text, which is performed at the receiver side. So here, these are some definitions for encryption and decryption. And what are the principles of cryptography? We need the confidentiality, integrity, authentication, and non-repudiation. Confidentiality means only the authorized user should be able to access the data. Integrity is whatever the data that is transferred, no one in the middle should be able to alter it. Authentication is the only the authenticated users can have access to what kind of information they can have access. And non-repudiation is denying the fact that I have done something, but I should not deny that I have not done something, right? That is what is non-repudiation. So when we say cryptography, there are few algorithms involved: symmetric, asymmetric, hashing, and digital signatures. So when I say symmetric cryptography, it is nothing but the same key is used for both encryption and decryption purpose. Okay. So what is this key actually? So if I say encryption, what does it mean? Converting the plain text to ciphertext. But how do I convert the plain text to ciphertext? For which I need some mathematical formula, right? Or some algorithm. That is what is referred to as key. Using the key, we are going to convert the plain text to ciphertext. So when I say asymmetric key cryptography, it is nothing but here also we are going to make use of the key, but the key here is two different keys will be involved. One is called the public key and the other one is called the private key. Okay. So here public key is used at the sender side. That is, sender is going to make use of the receiver's public key and he is going to transfer the information. Whereas in case of Receiver, what he is going to do, he is just make use of his private key and he is going to decrypt the information. Okay. So these are very much basics to symmetric key cryptography and asymmetric key cryptography. And the most important thing which is related to blockchain is the hashing algorithm. So whatever I have discussed, everything is given in this slide. These are some list of symmetric key cryptography algorithms. Asymmetric means both public key and private key will be used for encryption and decryption. These are some lists. And hashing is the most important thing that is related to blockchain. So hashing algorithm, what it is actually, you have some algorithm for which you are going to give some input. But the input can be of any size. It can be 1 bit, it can be 2 bit, it can be 1000 bits, it can be 2000 bits, it could be of any length. But the output is going to be what? It is going to be a fixed length output. Okay, whatever the output that we are getting as a result of hashing algorithm is called as the message digest, or it could be called as a fingerprint or hash or checksum. And the most important property of this hashing algorithm is you could see in this figure. Okay, the second and the third thing. In the second one, you see the red fox jumps over the blue dog. And the third thing you see, the red fox jumps instead of over what is written here, OUER, the blue dot. I am just giving both the input onto the cryptographic hash function. What is the output you see? How much difference is it? Even if I change the small letter in the input, a drastic change in the output is there. Okay, this is the most important property of the hashing algorithm. That's what is mentioned in all these slides. These are some applications. Let me skip all these things. It's not needed that much. And the final thing is digital signatures. So what is this digital signature? It is a cryptographic output which is used to verify the authenticity of data. That is, whenever we are sending some document, we are digitally signing the document. But how does it happen? As I mentioned that we have two keys, right? One is the public key and the private key. So when I say that I'm digitally signing the document, it means I'm just encrypting my document using my private key so that the receiver can decrypt it only with the help of my public key. Okay. So by which you can find that okay, this document is sent only by her and not by anyone else. This is how digital signatures are done. So when I say cryptographic algorithms, where it is used in blockchain. I mentioned that we are going to generate some transactions. So during transaction generation, digital signatures are used and some asymmetric algorithms are used. And then during creating the block, while creating the block, I'm just going to perform what? I'm going to find out the Merkle root. How does this Merkle root is found? Using some hashing algorithm, right? So during creation of the block, hashing algorithms are used. And then I said I will be communicating the transaction, right? It's not necessary that I should communicate the transactions as it is. I can encrypt my transaction and I can communicate. So encryption is used here. And finally, during mining, what is the mining process actually? As I mentioned, that some difficult nonce will be difficulty puzzle will be given and the miners are supposed to solve it, right? No, 10 minutes now. So next is the cryptographic algorithms used in blockchain. So here Bitcoin exists of SHA-256 algorithms and Ethereum exists of SHA-256 and KK-256 and other every blockchain framework make use of some kind of hashing algorithm and some digital signature algorithm. Okay, so here I just skip all these things. These are very much basic SHA-256 algorithm functioning. Let me move to this Bitcoin part. Okay, so here this Bitcoin is a form of digital currency that aims to eliminate the need for what central authorities. So how does it work? Here you see we have Bob and Robert. What they are doing, if he is sending some amount to his friend Robert. So he's just going to generate the transaction. All those transactions are added to the block and it is then broadcasted to the network. As I mentioned, we have some miners. What these miners are going to do, they are just going to check the validity of this block, and once they found that, okay, this is a valid transaction, then what they are going to do, they are just going to solve the puzzle. Once they have solved the puzzle, then the block that has been solved by the miner will be added to the blockchain. Okay. So this is the architecture. Here you have the users. Users are generating the transactions. All the transactions are sent to the memory pool. And from the memory pool, the miners are going to bundle the transactions into the block. They are going to solve the proof of work consensus mechanism. Once it is done, this block is then added to the blockchain. So let me skip this cryptography part in blockchain. We'll just move on to the research in blockchain, the most important thing. Suppose think that you want to do some research in blockchain. You understood what is blockchain and how does it work, what are the types of blockchain and what are the various versions in blockchain. But you don't know how to start the research in blockchain, right? How can you start the research? This simple slide could help you. Like when we say blockchain, there are different layers. The first one is the application layer, then data layer, consensus layer, then network layer, and then comes the platform layer, right? So when we say application layer, what you are going to do is simply design some application with the already existing framework. You don't do anything. Simply write the application using some Solidity code or something else and just deploy it. Okay, this is how you can start your application. If you want to do some simple research in blockchain, then start with this. Write a simple application in blockchain. Okay, now you have done with the simple application. You want to further move on to the next level. What you can do is you can work on the data layer where you can work on with the cryptography part involved. So try to make use of different hashing algorithm. Instead of SHA-256, you can go for KK-256. Instead of ECDSA, you can go for some other signature algorithm. Try to work with the data layer. Then comes the consensus layer. What you can do is, instead of proof of work consensus algorithm, you can go try your own consensus algorithm. You can find your own consensus algorithm. Hello, ma'am. சொல்லுங்க மேம். இல்லை மேம் போயிட்டு தான் இருக்கு. இன்னும் ஒரு 5 minutes. தேங்க்யூ மேம். So here next thing is if you are a group, if you are in a group of 5 or 10 members, what you can do is you can design your own framework, like how Hyperledger or Ethereum or
Excuse me,
Bitcoin
ma'am.
works. You can design.
Sorry to interrupt you, ma'am. Your voice is not audible, ma'am.
Your platform, and you can design in that framework. Yes, ma'am.
Excuse me, ma'am. Sorry for the interruption. Your voice is not clear, ma'am.
Is it audible now, ma'am?
Excuse me, ma'am.
Yes, ma'am. Is it audible now?
Ma'am, still your voice is breaking. It is not clear.
Hello, ma'am. It's not clear. Hello, ma'am.
Yes, ma'am.
Is it audible now?
Now it is okay.
Okay, okay. Just a few minutes then. Only different platform. So this is how the researcher has to start and do the research in blockchain. So whenever the researcher is doing the research on blockchain, there are three things that he should consider. The first thing is scalability, and then security, then decentralization. Okay. So far, no research is able to find all these three things in his work. If security is there, then scalability is not there. If scalability is not there, then he is not able to achieve the 100% security. So these are some functions of blockchain, like where we can make use of the blockchain. It could be used in finance, healthcare, land registry, insurance, digital voting, global trade, inheritance, government, and supply chain. So these are some of the applications which makes use of blockchain in finance. So I'll just let you know how blockchain is used in India. Like see here, we everyone know about the NIC National Informatics Center. What it is doing is it is making use of blockchain for designing 5 different products. And what are the products? Certificate chain, document chain, judiciary chain, logistic chain, and property chain. And 3 different organizations are involved, like CBSE, Ministry of Justice, Ministry of Consumer Affairs, and 7 states are involved in it. So here, this is how blockchain is used by the government. Other than this, government is also making use of blockchain for land record management systems. And for if you take this West Bengal Municipal Corporation, what it is doing is it is just issuing the birth certificate documents using the blockchain. And government of Karnataka, it is working on unified land management system. And in Tamil Nadu, it is hello ma'am. In Tamil Nadu, we are having this e-Petagam app. And government of Assam is also using blockchain for land record management system. And finally, now India is making use of this DigiYatra. DigiYatra is also trying to make use of blockchain for providing the contactless ticket systems. And this NIC has designed a national blockchain technology stack. So recently, for the Mahakumbh Mela, our Indian government issued the train tickets using these NFTs. Thank you. Hello, ma'am.
Dear participants,
And let me know if there are any queries.
if you have any queries, you may ask now, or else wind up the session now. Thank you, ma'am. Thank you so much for your valuable time. The session was very useful and very informative. Thank you so much for insightful inputs. Thank you, ma'am. And thank you, participants. Kindly
Thank you.
fill out the feedback form after the end of the session. Thank you all.